Hi. I think we're waiting for some people because they seem to be stuck at the coffee break. But I'll just do some introduction. I think shouldn't be not that hard. So the most interesting part are going to be the demos I'll be performing next. Anyway, thank you so much for joining the session about Quarkus. My name is Roberto. It's really a good pleasure to be here today. A really quick joke, I guess. So I used to come here very often to come sing concerts. I never imagined that I would be standing here at the stage doing a presentation in this venue. So it's quite interesting. I think the last one that I came here, that was like a couple of years ago, was seeing Amor a Mars. Not sure if you know about that, but it's a really cool band. If you like it, just have a look. So anyway, my session for today is called Developer Joy with Quarkus. So a quick raise of hands. Do we have any Java developers around? Okay, a few, or most of you. That makes sense, even though I can show you a couple of things that's not only for Java. Have you heard about Quarkus before? Okay, a few. And who's using Quarkus? Just one person. Okay. Thank you so much, sir. So I hope after this presentation, all of you will go home and start using Quarkus. Okay, so first thing, what is Quarkus? So Quarkus is an open source project and is mostly tailored to write Java applications. And what we like to tell about Quarkus is mostly tailored for running things on the cloud, for building microservices and doing serverless. Even though those were the main goals when we started Quarkus, people actually use it for everything. So if you want to build a monolith with Quarkus, you can do that. If you want to build command line applications, you can do that. So you can do a lot of other things with Quarkus, even though these were the main areas that we wanted to tackle when we started doing Quarkus. Now, the second thing they'd probably be asking is, well, why one more project? Why something else? There's already a bunch of them in our community, so why do we need something else? So why Quarkus? So let's go and take a step back and talk what we like to say, the hidden truth about Java and containers. So I'm not going to go into much detail, but just going to do a couple of really brief explanations. But I'll just say, when you start a Java application, right, there's a bunch of things that get loaded into the JVM. There is what we call a startup overhead, right? What happens is when you load classes into JVM, they never get unloaded. So basically, they're occupying memory. And I mean, most of the time, we don't really care about this, but there are a couple of things that happen in our industry that made us start to care about the memory usage of our applications, right? Now, the other thing is, well, I like Java. I hope all of you also like Java, right? And it started to get really, really tricky to talk to other technologies, right? Because, well, Java is actually memory hungry, right? And if you compare it with things like Node and Go, I'm not going to even start to discuss these technologies, just like a really hands-on comparison. So it's really hard to fight with those on the memory use case, right? And why is this relevant? So if you remember maybe like 10 or 15 years ago, all of you were just buying racks or buying these really expensive backend servers where it just, all of you know that what's really hard to get budget for that. But once you get it, you didn't really care what you put on those servers, right? You have a lot of memory. The upfront cost was already paid, right? So you didn't care anymore. Now, when you're running things on the cloud, which is what most people are doing these days, so who's running things on the cloud? Okay, like 50% of the room. What happens is you pay as you go, and you pay exactly what you use. So you pay what the memory you use, you pay the CPU you use. Now, the memory usage and the CPU usage become way more relevant these days than they were in the past. Now, one of the things that we tried to do with Quarkus was to actually lower those requirements on memory and on CPU, right? So if you compare it with a traditional stack, I mean, and these graphs are not on the scale, but just to show you like an idea, we're actually able to fit way more Quarkus nodes than a traditional Java stack, maybe WebSphere, Liberty, even Spring. Now, we like this approach, right? But we know that this is not the only approach that could bring us people to use Quarkus, right? So the other thing that we wanted to provide with Quarkus was a really, really cool developer environment where you feel compelled to program and what we like to call the developer experience with Quarkus. So we wanted to make it a very good developer experience. We also wanted to unify reactive and the imperative programming. So we know that reactive programming is something that people are looking a lot, and they're building more and more reactive applications. We know that's really hard to build a reactive application. So we also wanted to give a very interesting API, a very more simple API to use that. And we wanted to give a bunch of libraries that you already know, and I'll show a couple of them in a sec. So developer joy, that's actually how the presentation is called, and that's what I want to show you the most, is one of the things that people like about Quarkus, I'm going to show you in a couple of demos, is we hot reload everything, in the sense that you build your application, you start up Quarkus, you change your code, you don't have to restart, you don't have to redeploy, you'll see the changes as you write them, which is really, really cool. I know that there were a couple of tools that were able to do this in Java in the past, but none of them work like Quarkus. So Quarkus really has nailed this right. And if you're actually writing a code that you're not able to reload, that's a Quarkus bug, and you have to report it. Now, looking with a little more detail now, this is actually showing a couple of numbers. So a traditional cloud native stack, we usually see this is like a simple REST endpoint. We see like 140 megs in this particular case. With Quarkus, we usually see half of that size in memory, right? And if you're building Quarkus in native, and I'm going to show what native is in further into presentation, you're seeing like a tenth of the size. So we're seeing like 10 meg. So that's really impressive. Now, picking another example of a REST plus CRUD, so a couple of REST endpoints and a database. Now, a traditional native stack, you'll see like 200 megs. So on Quarkus, it's a little higher than we had on the previous example, but still way less than it was before. But again, native mode, we see like a tenth of the size. So those are the recordings that we're seeing. Startup time. So startup time, we're seeing like sub-millisecond startup time when you're running on native. So we're seeing like 16 milliseconds, 20 milliseconds, which is really great. And when you run it on JVM mode, you usually see even sub-second startup time, like 1 second, even less than that. So a really quick question. Who has an application that takes like 10 seconds to start? Well, pretty like 50% of the room. More than 10 seconds. Yeah, most of the room, right? So would you like to have an application that starts in less than 3 seconds? Yeah, so Quarkus will probably be able to do that for you. Again, looking a little bit in detail with the imperative and reactive, right? So in one hand, we have the imperative code. On the other hand, we have the reactive code. And you see they're really similar. You only change a couple of annotations, and you switch from imperative to reactive really, really quick. So the idea was, again, have a very interesting developing model in the sense that you were able to do, if you need imperative, you do imperative. If you need reactive, you do reactive. But you don't have to change your way of doing things. And finally, one of the things that we joke about as well is, well, Quarkus is around 3 years old now. But probably all of you already have like 10 years of experience with Quarkus. And the reason why, probably you recognize a lot of these logos, right? So you see things like Camel, Microprofile, Spring, OpenShift, Kubernetes, Hibernate, Vertex. So Quarkus is built with all these libraries in the sense that after the presentation, you can probably go home and start building a Quarkus app because you don't have to learn any new API. So the APIs that Quarkus uses are the APIs that already exist in the Java ecosystem. So do we have any Spring developers here? Yes, that's usual. Spring is a very popular technology. I love Spring. Now with Quarkus, we actually support the Spring APIs. So you can still write Spring APIs using Quarkus and have all the benefits that I'm trying to at least justify over here. So before going into some of the demos, let me just tell you how we're able to do all of this so you can understand that what I'm telling you is not really bullshit, right? So how Quarkus works. So if you look into a traditional framework, things like, again, Liberty, Open Liberty, or WebSphere, even Spring, right? So you write your application, right? And you have like a build process in the middle, using Maven, Gradle, whatever. And then the runtime is going to pick up that jar, or word, or whatever resulting binary comes out of that, and it's going to do a lot of things, right? It's going to do what we call class path scanning to search for like annotations and start up services and build a model of the application, right? So that's a lot of things that are happening. Now, what we do with Quarkus was we shift things around. And what we're doing is, instead of doing all of those operations when you're starting up the app, we're actually doing them when you're building the app. So in the sense that you're going to save a lot of time when you're actually going to start the app, because most of the operations were already executed during the build process. Now, if you think about it, this actually makes sense. Well, it is in my opinion, right? Because now let's just think about, you have an application, you're scaling it into 100 nodes, right? So the startup runtime of that app is going to be exactly the same for the 100 nodes, meaning that that's just wasted time and wasted memory on the cloud. Or not only on the cloud, but in whatever server you're running that. It's just wasted time. So if you're able to actually pre-generate or prepare all the same operations that are going to be executed beforehand, right, then you're going to save all of that time and memory. And if you think about it, you only build the application once, and then you distribute it to whatever 100 nodes, 200, whatever, right? So in our opinion, I think this kind of architecture makes sense, right? Now, this allows us to do a lot of crazy things and allows us to optimize a lot, the applications a lot, right? So the main architecture point of Quarkus is we move as much as possible to the build phase. We minimize the runtime dependencies, right? That just say you have to read an XML file, right? Well, that XML file usually doesn't change between the build and what you're running the app. So what we do is we read the XML file, we create all the metadata in Quarkus memory, we serialize it, and then what we do after is we can just drop all the XML runtime dependencies, right? Because we don't need them anymore. We don't need to read XML anymore. So less memory that your application is going to use during runtime. Now, this is just like a small example, but now think for that for a second. So if you apply this exact same pattern to everything, to all the libraries out there, then you gain up a little bit here, a little bit there, a little bit there. So in the end, you're going to get like a huge saving on memory, and because you're going to be executing less operations, then less CPU during runtime. So all of this was done with a single goal in mind, which was to be able to run Quarkus in GraalVM as native. I'm going to tell you what GraalVM in a sec, if you don't know about it. But basically, this was one of the main goals that we wanted to do with Quarkus. So yeah, this is just a couple of examples of what a runtime usually does, like parse configuration files, class path scanning. So class path scanning is one of the things that takes the most CPU and memory, especially when you have like multiple libraries in your class path, because they don't know each other, right? So most of the times, each library has its own class path scan, meaning that it's really usual for you to see, like, when you're starting up, having like 50 or 60 scans to the class path. So one of the things that we do in Quarkus, because during the build time, we do like a single class path scan at the beginning, and then we just create a dictionary of stuff, and then we just feed every library what they actually need. So probably you'll be asking, well, because you're doing all of these things during build, is your build process going to be slower? Yes, a little bit, but we're talking like 2 or 3 seconds, right? Because we do optimize a lot of other things. Okay, so in the end, the main benefits is we do the work once, not at each start, right? A lot of these bootstrap classes that I mentioned, like XML parsers, XML readers, things that like you only execute once, we don't need them anymore, so we can just drop them. So less time to start, less memory, and we also try to get rid of all the reflection, all the dynamic proxies, right? We can just look into the code, and we can just like replace that with direct bytecode calls on your application. So I know this is like very technical things, but I think that this explanation really tells you how Quarkus works at the architectural level and how we actually able to get all the things that I explained in the first couple of slides. Okay, native image. So native image is one of the things that people are like the most on Quarkus. And anyone here heard about GraalVM before? Okay, a few. So GraalVM is a virtual machine coming from Oracle as well, but has a couple of different things that the regular VM, like Hotspot, does not have, which is it comes with what we call the truffle compiler, which is actually able to create like a polyglot virtual machine, so you're actually able to run Ruby, JavaScript, Python with Java, and I can show a couple examples with that. But the other thing they also have is they actually created what they call the native image compiler, which is it picks up a Java application and then it's able to build it natively. So you just hand up with a native executable. You don't have JVM anymore after that, but you have something called Substrat VM that runs all the native executable. But if you think about how a native executable works, well, it's not dynamic as a JVM, so you're not able to like load and unload stuff, right? There is no dynamic class load. There is no class load at all, right? How is reflection going to work, right? So that's why we have to do a lot of these optimizations beforehand to actually be able to build it to native, right? So a couple of the limitations of GraalVM when you run into native is, well, there is no dynamic class loading, right? You have like a closed world assumption of your application is a native executable. So there is no, you cannot load and unload stuff. And there are some things that do work, but you need to manually configure that, right? So for instance, even though reflection works, we have to manually say what are the reflection calls that we're going to use, right? Because if we don't tell that, then GraalVM will have to include the entire JVM ecosystem that you have on your app because it doesn't know what you're going to call during runtime. So one of the things that we do with Quarkus is we analyze the application and we just say, okay, these are the reflection calls that are required. So then GraalVM can optimize and include only what it needs to run the app. Okay, so though the slides are mostly done now, I'm just going to go and show the demos because I think those are the cool things. So sorry about all of this jibber jabber, but I think it was interesting for you to figure out a little bit about Quarkus on the theoretical level. So let me show here. Oops, sorry. Let's go here to IntelliJ. Is black okay, or do you want to change to white? It's okay? Wonderful. So I have here a really small application. Well, I actually have, sorry, I have two. And let me see, okay, I have a lot of time left. And let me show you a couple of some things on the code here. Well, let's just start with this one, right? And that one, right? Oops, sorry. Do you recognize this code? Yes, it's familiar. Even if you haven't tried it before, it is familiar, right? You've probably written things like this in the past. So if I show the imports, what you're seeing over here is just things like Eclipse microprofile and Javax, now Jakarta. I'm going to show you the Spring version later on. But what I'm going to do over here is I'm going to go to my Java sources. I'm going to go find files, and I'll search for Quarkus. And what you see here is, other than the package name, which I name my project, there is no Quarkus things over here, right? So all the code that I have written for this Quarkus app, you probably already written before. So we have like a very low entry barrier to get into a Quarkus app. Now, what you're going to see Quarkus things is going to be on the POM file. So I'm using Maven over here, but it also works for Gradle. So all the magic is actually executed here on the Quarkus Maven plugin. That's where we do all the stuff that I mentioned during the theoretical part. And then what you have here is just Quarkus dependencies. So one of the things that I want to clarify on Quarkus is Quarkus will run with any library on the Java ecosystem, right? But one of the things that we do is we usually pick up the library and wrap it into what we call a Quarkus extension. Why would we do that? So we do it to optimize the running of that library into Quarkus, right? So remember when I mentioned that we need to know what are the function calls that we're going to execute on the native image, right? So that's one of the things that we do on the Quarkus extensions. So the idea here is if you pick up a library on the ecosystem to run on Quarkus, it will definitely run on JVM mode. We don't know if it will run on native mode because it requires a couple of extra things. If you run everything with Quarkus extensions, then we assure you that it will work on native mode. So that's why you see these differences over here. But yeah, what you see here is just like just like simple dependencies on code. And if you really want to, when you want to start like, oh, I don't have internet. Okay, let me connect here. Okay. But if you want to start, my recommendation is you come to code.quarkus.io, right? And then you can just start a Quarkus app. So let me just, okay, there you go. So these are all the things you can add to a Quarkus application using Quarkus extensions. Again, you can use whatever library you want. Those are the things that we assure you that work on native. So there's a bunch of things over here. And after you're happy, you'll just generate your app, and the app will start ready for you. But I'm just going to go with this because I already have it right here. OK. So the first thing I'm going to do over here is I'm going to run Quarkus dev. So this is running Quarkus in development mode. And this is one of the things that I like the most about Quarkus, especially when you're developing an application. That's usually what you want to do, right? So now Quarkus is running. And so if you remember what I was doing over there, so it's just a simple REST endpoint generates a random number. In this particular case, just the idea is to generate an ISBN for a bookstore to create a book, right? And now, well, I want to change that. So what I'm going to go do is I'm going to go to this generate number, and I'm going to say, well, hello, Porto Tech Hub, right? And I only changed to my terminal. I haven't redeployed, I haven't restarted Quarkus, I haven't done anything. I'm just going to do a curl again, right? And there you go. So nothing, right? And well, you may say, well, that was a very simple use case, right? I'll just change like a simple string. Well, let's go with a more complicated example. Let's do like a proper hello world. So I'll just go over here and I'll just, well, let's copy this, I guess. I'll just write one. Response, well, hello. And this is going to be a get. And pad a proper hello. OK, I need to implement that method. OK, there it is. And well, let's copy that. And well, let me add a couple of exclamation points over there, just to make sure that we're fine. So that was on number/hello. There you go, right? So one of the things I'm going to tell you with Quarkus, if you're doing, so the idea is that you're going to always have this experience with Quarkus. If you're doing something on the code and Quarkus doesn't reload, that's a bug, and you should report it. So everything that so you're able to do like create new REST points. You can even create like new columns on a database. Quarkus will update everything automatically for you. Yeah, so these are library load features. So people love this a lot, and I think that all developers really are going to really enjoy that. So let me just roll back all of this, and I'm going to do like something a little bit different, so you can actually see even a more powerful dev reload. Let me see if I have that over here. No, history. Okay. It's on then let's clear that. So just with a couple of properties that I'm passing over there to Quarkus, you'll see something like Quarkus container image build, right, and Quarkus Kubernetes deploy. So what I'm actually doing with Quarkus is I'm just building Quarkus as a Docker image, and it's going to be deploying to my Kubernetes cluster running locally on my box. So, oops, it failed. Why? That shouldn't fail. Let me see why. Oh, I know why. Okay. It's the default namespace of kube that was missing. So that should be working right now. So one of the things that Quarkus is actually going to do now is not only is building with tests, but the integration tests are going to be executed with the Docker image that was being built. So it's just building the Docker image with Jib. After that is done, integration tests are going to be executed against that Docker image, right? Running with my Docker environment. So hopefully, you'll see that it's pulling the image that was just built. So all of that is done automatically for you. And now, if I clear that up and I say, well, not like this, kubectl get pods. No, kubectl get pods. Okay. So that's running. And now let's say kubectl logs number. So now Quarkus is running on Cube. And well, this doesn't exist anymore because I rolled back the code, so this doesn't exist. Now what I'm going to do is I'm going to run Quarkus remote dev. So what do you think that's going to happen right now? So Quarkus is actually connecting to my pod on Kubernetes. It actually connects to all of them. And now I have the exact same developer experience that I have when I was running locally, but now on Kubernetes. So if I come over here and I go hello Porto Tech Hub again, and hit that, it's going to take a little longer because, I mean, it has to push things to Kubernetes, but you get the exact same developer experience, but now running in Kubernetes. And notice something. So I have to run it over here. kubectl logs. So we didn't redeploy the pod. What we did is we actually updated the Quarkus app running on the pod. So we're not redeploying the app at all. We're not reusing, or we're using the Quarkus instance, but we're not redeploying the pod. So everything happens on the same pod. So why is this useful? Well, let's just say you have your organization. They have like a bunch of things running on Kubernetes already, like databases, Kafka queues, and you want to connect to that and develop something. Well, that's a way how to do it without having to redeploy all the time. Okay, so that's remote dev and normal dev, I'll just say. So let me just delete this. And let's roll back this one again. Okay, so let's run Quarkus dev again. So I'm running it locally. And now you're going to notice there are a couple of other things here on the terminal, right? One of the things is here, so it's on the bottom. It's how the console works, so I'm not able to pull that up. but you see something here like resume testing. So I'm going to hit that. So resume testing is actually our continuous integration testing feature. What happens is every time you change something on the code, Quarkus will automatically run the tests for you. So what I'm going to do here is I'm going to actually add a new test. So this is probably the only Quarkus-related API that you're going to see, which is, so now I'm going to create a new test. So I'll say number resource test. And the Quarkus API I mentioned is Quarkus test. So this is like a annotation coming from Quarkus. So the idea, this is using JUnit 5. And this is to just tell JUnit to run the test in a Quarkus environment. So, but you don't need any other, you don't need any other thing for this. Now let's just say like, well, test, and say test. And I'm going to copy this from here. So this is actually just testing the REST endpoint using rest assured. So if you go to the terminal, I haven't done anything yet. And now you'll see like Quarkus is compiling that test and saying running, and it passes, right? They say all tests are passive. But notice that it says one test was run. So even though I have other tests in the system, and I can show them here, which basically is just testing the configuration, Quarkus was smart enough to understand which test was modified and which ones they have to execute, right? So if I come over here and I change the number resource and say, well, hello, and go to the terminal, now you'll see like one test was run and now it failed. But notice only that test was executed, right? Because we were able, basically Quarkus, what it does is it just inspects your application, notice which code was changed, knows which test affects the code, and then only that test is executed, right? So if we want to fix that, right, we'll just, we just replace it back, go to the terminal, and now everything is passing again, right? So this is our continuous integration feature, continuous test integration, I guess. So I'll stop Quarkus dev now. I'm going to move to another app. So let me just roll back that one. And let me see how much time I have left. I think 15 minutes, I think. So that should be enough time. So here I have another service, and now you'll see this one is a little bit more complete, I'll say. So you have so this is just a bookstore. So it's like a CRUD, right? So you'll see like resources to like get, create books, right? Update them. So there's also a database over here with an entity manager, so it's using JPA. So like a real traditional application, like probably all of them have done in the past. You're also going to see here, I think it's on this code, not this one. No. Yeah, so in here, there's also a couple of reactive messaging APIs. So it's using Kafka to just store some things. So only by looking to my application, I see, well, there's a database involved because there is JPA, there's a reactive messaging thing, so maybe it's using Kafka or something else. So my concern will be, well, how am I going to start the database? Well, how am I going to start Kafka? Doesn't really matter. So what I'm going to do, again, is going to run Quarkus dev. So Quarkus is going to be smart enough. It's going to look into the app. It's going to look into the configuration. If not able to find like a proper configuration to hook up to a database or to a Kafka queue, it's going to create one for you. So of course, it's going to use Docker for that. So it's going to take a little longer to start because you have to start the services. But if you see over here, so I mean, it's a little bit hard to notice on the logs. But yeah, you'll see like running, pulling images. I'm trying, so this is the Postgres one, trying to see, look for the log that says that started. So pull complete, dev services started. So this is what we call dev services, right? And I'm trying to find over here, okay, where is the database connection? So localhost, I'm not going to be able to find it. It's really tricky to find it when you have the terminal this big. So that's the collector. It should be on localhost, wherever. Never mind. I just cannot find it that on logs. It's just, but I wanted just to connect to the database to see that it was there. But I think you believe me that actually run a database. Now, I'm going to stop this, and maybe one of your concerns will be, well, I'm not able to run a Docker environment on my box because my organization doesn't allow that, or I don't have permissions to install Docker. Well, that's fine. I'm just going to quit my Docker desktop, and I'm going to run this again. So do you think this is going to work or not? Who says it's going to work? Okay, if you, the rest of you don't think that's going to work. Well, actually, it's still working. So now what we're actually doing is we're using the test containers clause. We hook up, so if you're not able to find a Docker container locally, we hook up to the test containers clause. We create all the Docker images over there. You're going to be able to have all the environment and develop as usual. And when you kill Quarkus, we just drop everything and you're done. So I think this is a really cool feature because it allows like a really quick bootstrap. You don't have you don't have to tell anyone, well, you have to set up this database, you have to set up this Kafka key, you have to set up all of this. Well, Quarkus will do all of that for you when you do it in dev. So that's what we call dev services. Now, I don't remember this code on memory, but let's go to number service again, and let me show you some Spring stuff, because I know there are some Spring developers around. I have 10 minutes left, right? It's 12? It finished? Do you know what time the session finished? Is that 12, right? Okay. Sorry about that. Okay, running in dev. And I'm just going to unshelf a few things over here. These are the Spring stuff. So let me just unshelf this POM first. And sorry. Let me show you the POM. So the POM, I just added a couple of Spring dependencies coming from Quarkus, so the Spring Web and also Jackson. Doesn't really matter. So let's look into what happened over here. Okay, so it failed. Not sure why. But it should be up. Let me just curl this one. Okay, so not sure why this is failed. Maybe because I forgot about something. Well, let me run that again. I probably have some things wrong on my. Okay, so let me just, because I'm just adding and removing a lot of classes, then like there is like some trash over there. So that's one of the things. So yeah, there's not an excuse. The problem is when I just add classes and then I just remove them, they'll still be on target of Maven, right? Even after moving from the IDE. So that's why it was failing. But now everything's okay. So yeah, so I added like this Quarkus Spring Web, right? And yeah, again, I don't remember that code by memory. So I just go on this greeting controller. Let me just do on shelf here. And yeah, let me just refresh that. So the IE imports, okay, that's done. Oops. So you recognize this, right? This is string code, right? So if I import, you'll see the string stuff over there. So this is on greeting. So let's go and say greeting. There you go. So that's probably from one of my latest things. But just say, even though this is Spring code, you have the exact developer experience that I've shown you before. There you go. Now, let me just unshelf a couple of other things over here. So if you want like a Spring Bean, that's also possible. I could probably just go that, but right, so you have something like this. Well, just like a proper greeting. You say this is a component. You come over here. You say like, was that greeting? Yeah. Greeting. Greeting. And you say like auto-wired, right? So are you guys seeing like an issue with this code? Yes, I'm not calling, but this is only an interface. There's no implementation, right? So what happens on Spring when you do something like this? It only fails on runtime, right? And then usually, those are the things that I usually like to call the ticking time bombs, right? Because you never know when that code is going to get called, and then sometimes that happens. But that does not happen with Quarkus. So if I come over here and I'll say, oh, sorry, I'll say Quarkus and Quarkus build. I have 5 minutes left, so there's one last thing. Oh, so let me see. Okay, so that actually didn't work out because Quarkus is really even more smart than me. So let me just add something like this. So Quarkus actually noticed that that bean was not even used, so it removed that. So I have to put something that actually calls that method. Okay, so now what's happening? I think I'm missing something, can't remember what. Let me see, controller, auto-wired. I'm not really a Spring. I used Spring in the past, but number. So that should actually work. Well, the point is, Quarkus should actually be able to figure out that that bean has no implementation. It's going to blow up on runtime, and it should actually have an error. But I can't remember why it's not detecting that. Yesterday, it was working fine, and I haven't changed anything. So yeah, I'm not going to waste more time with this. I have to check what's happening later. Okay, anyway. So the last thing I'm going to show you, let's just roll back that again. And now that's clear. So I'm going to run, now I'm building Quarkus as native. So do we have any C developers around? Or someone that built C applications in the past? No? No one? Well, it was just to make like a quick joke, but the point is, here's kind of like building a C application. We're actually building an application for a particular architecture, right? So it's not like a quick build like you do it in Java. It's going to take a long, long time to build, right? Because it has to like inspect the app, it has to like replace everything with binary, it has to like do all the initializations, like inspect the code. So that's what usually happens when you're building a C app. So you've seen the exact same experience over here. So recommendation here is you're not going to build for native all the time. Yes, you'll just develop the app as I show you in the previous demos. And when you're ready to deploy the app to a staging environment or prod, then you build it to native. You can even let the CI do it for you, right? So that's not something that you want to do all the time. Ideally, you just want to develop in VM mode, and then you just build it to native. So only with that command is building that for native. I also have GraalVM installed, so if you use things like SDKmon and install GraalVM, Quarkus will auto-detect that, and it will point to that GraalVM. You also need to have the native image package installed, but that's just like a setup that you've done at first, and then you're done. So it should be mostly done. So yeah, it takes a while. Okay, and I'm going to do something that you should never do, right? So please never do this, right? So that's a binary file, right? You believe me, that's a binary file. So how do you run binary files? Like that. Boom. So let me see how much that took. Where is this profile? You can see number. Okay, started in 40 milliseconds. So let me do that again if you didn't see it properly. Boom. Right? So that's running Quarkus in native. It has the exact same experience, well, not developer experience, right? Because you not have the hot preload in this particular case. But if you curl the app, right? So you have the REST endpoints, and they're going to be over there. So if I go to monitor, and let's search, I'll just going to increase that for a second, and I'll search for number. Now you're not looking for a Java process, you're looking for the number API process, right? So you'll see the number API running is only 18 meg. Right? That's pretty impressive. Now imagine how many nodes you can have running on native. Okay, so that's native mode. And yes, I guess that was the last thing that I wanted to show you. I only have 1 minute left, so I'm really happy to take questions or if you want to take them outside. Okay, there's a question. I have a couple of T-shirts. I'll give T-shirts for people that ask questions.
Hello.
Hello.
My question is regarding debug.
Debug.
So if you compile with the Quarkus and you shake everything that you don't need, what is the experience of debugging?
Debug is exactly the same experience that you have, right? So the only thing is, for instance, on native, you cannot use the JVM debugger for that. There's debuggers for native binaries. But you have the exact same developer experience that you expect on a Java runtime. The only issue is, well, not an issue, but for instance, if you're expecting to find, let's just say, a read XML of Quarkus on runtime, you're not going to find that call when Quarkus is running. You have to find that call when Quarkus is building. So basically, instead of debugging, so you may have to debug the Maven process that's building Quarkus, because that's where you're going to find the Quarkus call that you want to search for. Right? So that's the only difference. Instead of just debugging the runtime that's running the app, you may have to also debug Maven, because that's built and that's where the code is going to be executed.
Thank you.
You can come here and pick a T-shirt. More questions? Over there.
Hello. So my initial question was about the build time, but you covered it pretty well in the end, so I don't have any doubts about it now. But my question is, we mostly do Kotlin at the office now. If I want to code in Kotlin for Quarkus,
Quarkus supports Kotlin out of the box.
Yeah, I just need to add the Kotlin libraries, no?
So you can. So right now you can write Quarkus applications either in Java or Kotlin. That's the only language that we support right now. There is like some experimental support for Scala, but both Kotlin and Java are fully supported, and everything that I show you here will also work with Kotlin.
That's great. Yeah.
You can come and pick a T-shirt.
Yeah. Thank you.
A question over there?
Hello.
Hello?
In the beginning of your presentation, you said that Quarkus removes, or I understood like that Quarkus removes the necessity of the changing stuff in runtime. But sometimes we need it, for example, for logs. You need to change the log level in runtime,
Yeah, but
or there.
that's okay. So we have like what we call multiple configuration phases. So we have configuration that we call build configuration that's only applied to build. Then we have configuration that applies to both build and runtime static. And then we have configuration that applies to runtime. So for instance, logging, you can change log configuration and just like change the log levels, right? So we only remove stuff that we know that's not required dynamically, like logs. Right? So things like logs, yeah, we'll keep that, and you can change log levels and log appenders at runtime as usual. Right? Other things, like I explained, for instance, when you're picking Hibernate, and we have to look into the entities, right? So the meta model that we build for the entity is always going to be the same. So in that case, we just remove that code, right? For
Yeah.
logging, we don't.
But if you load your config file and never look to it again in your memory, but you do want to make a change in your config file in runtime.
Well, for instance, on the configuration, you can feed configuration as external file. You can use system properties, you can use environment variables, you can use console, Zookeeper, wherever, and then we'll read configuration from there, and we'll configure Quarkus on runtime with the configuration we read from those systems.
Okay, thank you.
So you can, for instance, change the log appender or the log level with a system or environment variable, and we override Quarkus log levels with those configurations, and we'll just change it dynamically. I think that we have to leave. Not sure. Do you still have time for questions, or I'm happy to take them outside. Feel free to come and pick a T-shirt as well.